Hey folks, I'm going to spend some time going through our two homework assignments this week because I think they're the first ones that get properly tricky. Chemical nomenclature is something that most general chemistry students don't love when they get started with it. It is a really important topic because you want a unified language that chemists all around the world can use to talk to each other about chemistry. I'm sure you can imagine how awful it would be if we called the same compound two different names or used the same name for two different compounds. Could cause a lot of confusion and maybe even danger in the chemistry lab. And so we developed this one system that encompasses all of the possible chemical names. And I'm going to walk through some of our homework problems that we use to describe these different compounds with you today. All right, to start off, we're going to be doing the first of the two assignments, which is chemical formulas. And so we're going to be taking names and turning them into their symbolic representations. Notice that we have this little blue box here. You're going to find these in many of our homework assignments. This gives you essential information for how to answer these homework questions. If you're struggling with the syntax in these problems, perhaps you're not following these rules correctly. Notice it says subscripts of 1 are not written. This is true both in our homework problems and also in the real world. It's a little redundant if there's one of something to say there is one of it. We just simply don't write that there are more of them, and then people can assume, that means there is one. We're only going to use parentheses for our polyatomic ions. Hopefully you've done the reading before you tried doing these homework problems. Polyatomic ions are collections of atoms that are stuck together covalently, but that ball of atoms has a net charge to it. And so they travel around as one group and behave just like other ions do. Subscripts are indicated by the underscore symbol because the lumen-ohm homework system isn't complex enough that we can have superscripts and subscripts. We're just going to use the underscore to say this is a little number now. And so we would write CO2 like this, CO underscore 2. Another couple of notes on the syntax for these problems. You want to make sure that you are spelling things correctly. Use the periodic table in order to make sure you're doing this correctly. You'll always have a periodic table available to you on your exams. Please also be using a polyatomic ion reference sheet. I'm also going to make one of these available to you. Now, there's a lot of different reference sheets out there. There's a lot of variability for which elements, which ions are included. The one you get on your exams will probably look different than these, but it will contain all of the information you need. Make sure that you're using the American spelling. The English spelling is a little bit different for some of these atoms, for some of these ions. For example, they say aluminium. There's an extra I in it, and the lumen-ohm system is just expecting aluminum. All right? So double check your spelling on all of those. Also note that capitalization matters. When we look at the periodic table, we notice that every element is represented by either one or two letters. Every first letter is capitalized. Every second letter is lowercase. This helps us to figure out where elements begin and where they end. For example, I can look at hydrogen and then compare to hafnium. So if you see something like capital H and then a capital F, you know that that is hydrogen attached to a fluorine to make the acid hydrofluoric acid. Whereas if you see a capital H and a lowercase f, that is an entirely different element called hafnium. And so it is really important that for readability you use capital letters at the start of elements and then lowercase letters if it has a second letter in it. All right, without further ado, let's get into some of the questions. So what is the formula for phosphorus acid? anytime you see acid, that is one of the three big classifications for nomenclature we use in this course. All acids are going to have hydrogen in them, and that hydrogen is always going to be the first element shown. And so I know it's going to start with an H here, and of course a capital H because it's the first letter of a given elemental symbol. Then I'm going to be thinking about phosphorus acid. I note that the hydrogen is not mentioned in front of phosphorus acid. That's because we can subdivide the two types of acids into the binary acids and the polyatomic, or sometimes called the oxy acids. Binary acids are made up of two things. They are just hydrogen and the other element. You can tell something's a binary acid from its name because it'll always start with hydro. Now, because phosphorus acid doesn't start with the hydro prefix, I know it must be the other type, which are the oxy acids. Those oxy acids are going to be hydrogen and then some polyatomic ion. And so I'm going to be looking at my polyatomic ion reference to try and find something that matches phosphorus. I see we have phosphate here. It's weird that this one doesn't include phosphite. Oh, that's not what I wanted to do at all. Okay. Like I said, there's going to be some variation between these. Many of them will have both phosphate and phosphite. Here we go. Here's the one I was looking for. So we have phosphate is PO4, phosphite is PO2. Neither of these matches phosphorus, but that's because we changed the suffix of the polyatomic ion when we turn it into an acid. 8 becomes us, and ite becomes... Oh, I'm so sorry, I said that backwards. 8 becomes ik, and ite becomes us. Let me write that down here. So we have 8 as a suffix becomes ik acid, and ite becomes us acid. And so because our chemical name was phosphorus acid, that kind of cues me in that we are talking about the ite suffix. And so going back over to that polyatomic ion list, I see that phosphite has PO3 3- as its charge. So we have P, big O, little 3, and then a superscript 3- here. That charge is really important when it comes to balancing our chemical formulas. So hydrogen is the first element in the first column of the periodic table. Everything in that first column is going to have a +1 charge. Everything in the second column, a +2. The transition metals tend to be a little bit weird. We'll probably talk about that more later on. And then we have on the far side of the periodic table, fluorine starts as -1, oxygen -2, nitrogen -3. So those are some basic rules for predicting monatomic charges. Going back to here, oops. The hydrogen is going to be a +1 charge. What we're trying to do when we draw these chemical formulas is we want them to have a net 0 charge. So I have to figure out how many hydrogens do I need to balance the 3 minuses. Because hydrogen is +1 and the phosphite is -3, I need 3 hydrogens in order to make this balance. There's a little trick you can do. You can take the plus, you can take the 3-, and you can just have them swap partners. And if you do this trick where the superscripts become the other element or ion's subscript, you end up with a balanced compound 99% of the time. And so this is going to be H subscript 3 PO3. Notice that there is one phosphite, but I am not putting it in parentheses and including the 1 because that's the syntax that the homework problem asked for. When we go back over to our assignment, we're going to type it in as subscript 3 and then capital P, capital O, subscript 3. And that should be the right answer. Let's do a couple more of these. Let's see, barium chlorate, that's another good one. Barium on our periodic table is going to be right here, is in the second column, and so that tells me it's going to make a +2 charge. It's helpful to write that down as you go along. So that'll be Ba 2+. And then I'm looking at the other compound or ion here. I see it ends in an ATE. If it ends in ite or ate, you know it's going to be a polyatomic ion. So I'll take a look at my polyatomic ion reference sheet here, and I'm looking for chlorate, and I see it right there. It's kind of hard to read that one on my screen. Let's see if we can find a better one for you guys. Chlorate, right? Yes. This is a good one here. All right, so chlorate is ClO3 with a -1 charge. And so I'll head back over to my drawing here. We have ClO3 with a -1 charge. I know that my compound has some barium and has some chlorate, but I have to figure out how much of each. The simplest way to do this is to swap the superscripts for subscripts like we saw in the last problem. So I'll take the 2+, I'll take the 1-, and I'll move that here, and this one goes over there. And so after I do that swap, we'll find that we have 1 barium, because the -1 would have been a 1 value, and then we have 2 of the chlorates. Because there are multiple polyatomic ions, I do use the parentheses here. So I'll open a parentheses, write ClO3. That all stays together as the polyatomic ion. I close my parentheses, and then I say how many of that polyatomic ion there are. There are 2 chunks of the chlorate attached to this 1 barium. Now we're going to go and take a look back at our homework assignment, and I'm going to type this in. So BA, remember it's got to be a capital B, little a, and there's just one of those, so I don't include a subscript. I open a parentheses for the chlorate. It's a capital C, little l, capital O, because the chlorine is one element and oxygen is the start of a new element there. There are 3 of them, so I do a subscript of 3. I close the parentheses because that is 1 polyatomic ion unit, and we have an _2 to indicate that there are 2 of that unit. There you go. I'm going to end the first video here so that you guys don't have to listen to the whole thing and scrub back and forth if you're trying to find a specific type of problem. I'm going to publish a couple more of these too. Thanks for listening. Keep up the good work, and look for more in the next video.